Hello, my name is Sarah Bhattarai. My partner is named Annette Cumins, and we work for Utah State University as STEM educators for 4-H in Weber County. Today we're going to show you 3 chemistry experiments. The first one, we are going to change the pH level of cochineal shells, which will change its color. The second one, we'll use the ideal gas law to make a cloud in a bottle. And the third one, we will use phase changes of matter to create sublimation bubbles. All right, take it away, Annette.
Hello, my name is Annette Cumins, and today we would like to do a little bit of chemistry. I am going to show you how to make something change color. So we are going to use an organic object called cochineal shells, and then we are going to add some liquids to those cochineal shells. We are going to change them from red to purple to orange. First of all, you need some cochineal shells. These are actually beetle bug shells, and you can order them online. You just take a pinch of cochineal shells and you put them in your little bowl, and you get your little pestle here and you get to smash them up into powder. We are going to take these and put them in my petri dish, which has 3 different sections. So I'm going to put a little bit of powder of this cochineal shells. Cochineal shells are organic substance, and they are used quite often in cosmetics. Sometimes they use them in food. So we are going to use today soda ash. Soda ash and water. We're going to use water, and we're also going to use a combination of vinegar and water. So after you get your little powder and put them in the petri dish, just like this, we're going to add 3 to 4 drops of each substance. So I'm going to start with the vinegar. Stir it up a little bit, and I don't know if you can see, but it's kind of a reddish orange dye when we add the vinegar to the cochineal shells. In the next section of our petri dish, we will be putting just some regular old tap water. Stir it up a little bit with my other pipette here, and you're going to get a kind of reddish purple dye with that. In the next one, we're going to add our soda ash water combination into our 3rd section. Here's our next little drops of water, and my next pipette, I have a little bit of purple droplets. I also have some pH paper here, and I'm going to take some of these droplets from each of these different sections, and we're going to put it on our pH paper and see what colors we come up with. And the first one I did was the soda ash combination, which makes a dark purplish blue color. I don't know if you guys can see that on the camera, but I'm doing my best. The next we're going to do is we're going to go with our reddish, which is just plain water. And we're going to put a few drops on there and see what color comes out on our pH paper, which it is like a dark red, almost a burgundy color on this paper. So, and I'm going to get our last one, which would have been the vinegar and water combination. I'm going to put it on the end over here. We have an orange combination. So it goes from orange to red to purple when we do those different liquid combinations with our organic cochineal shells. This is how they would make, if you were working as a chemist in the cosmetic industry, for example, you could make orange lipstick, you could make red lipstick, or you could make a purple lipstick. And that is how chemists combine colors and make different things with color.
Hi, my name is Sarah. What I want to do is create a cloud inside of a soda bottle. This is just a 2-liter soda bottle. On top of it, I have a fizz keeper you can find at Amazon for about $10. And then also I have a thermometer on my soda bottle. Right now it's saying my soda bottle is about 75 degrees Fahrenheit or 24 degrees Celsius. I'm going to show it to you up close. Also, you can see at the bottom, I have some liquid. That liquid is just rubbing alcohol. And it's really popular right now for disinfecting, and so is hand sanitizer. Now, hand sanitizer and rubbing alcohol are kind of similar in that the hand sanitizer has ethyl alcohol as one of its ingredients. It also has isopropyl alcohol. Now, when you use hand sanitizer, when you rub it on your hands, what happens to it? You just kind of feel it evaporating. It evaporates really quickly. Rubbing alcohol is the same. So for my experiment, I'm going to shut the fizz keeper tight and I'm going to start pumping air into my soda bottle. Now this can take a while. So while I'm pumping, I'm going to talk to you about the ideal gas law. PV equals nRT, where P stands for pressure, V stands for volume, N is the amount of substance. In our case, it's the isopropyl alcohol vapor. R is the ideal gas constant, and T is temperature. With this equation, N and R are constants. But for our situation, with the soda bottle, V is also a constant because the volume of the soda bottle never changes. So what we are left with is pressure and temperature, which are the two variables. And pressure and temperature are not equal to each other, but they are proportionate to each other, which is what this symbol means. When the pressure goes up, the temperature goes up. And when the pressure goes down, the temperature goes down. It's getting harder to pump it. It's getting pressurized. Pressure. It is very full. And the temperature's gone up. It says it's at 28 degrees Celsius or 82 degrees Fahrenheit. Why is the temperature going up? Remember, ideal gas law, pressure is proportionate to temperature. Right now the pressure is really high, which means the temperature is really high. When I open it, the pressure will drop like that, which means the temperature will drop like that. And when there's a sudden drop in temperature, what happens to all of the alcohol vapor inside of my soda bottle? Well, hopefully it will condense into a cloud. Okay, let's give this a try. It gets kind of loud. All right, 3, 2, 1. It's a cloud. Cloud in a bottle. Look at this, cloud in a bottle. Oh, and my temperature dropped down to 26 degrees Celsius right there. Okay, check it out with my laser pointer. Can you see it? Oh man, that was loud. Here we go. Yeah, you can see the laser pointer through the cloud. How cool is that? Ideal gas law. This is the ideal gas law in action. The ideal gas law is used in chemistry, it is used in physics, it is used in thermodynamics. It's a really important equation to remember, and it's also a really simple equation to use. All right, thanks for watching.
Today our subject is sublimation bubbles. We are going to turn our dry ice from a solid, this is our dry ice, from a solid to a gas without passing through the liquid stage. I'm going to put my goggles on and we are going to prepare our jars, our containers here. We're going to fill it up just until the neck. So first of all, I'm going to dip my hand and I'm going to prepare the tops of my containers here. We are going to make a crystal ball and it will be pretty fun. So when you're looking at dry ice, you'll notice that it is solid. We know that objects have three forms usually. They are solid, liquid, or gas, and usually it goes between a solid to a liquid to a gas. We are going to do sublimation. Sublimation means going straight from a solid into a gas, and that's what we're going to do today with our little chips of dry ice and our bubble solution in our water. First of all, we're going to put our dry ice into our warm water and we're going to start it, and it's already bubbling up. It's not even, I didn't even have to use my other thing, and it's just making some bubbles. But I want to make it into more of a crystal ball. Now this is pretty safe to touch. It's not going to harm you. What is happening here is our liquid is trapping the ice. Now look, it's forming a crystal ball all by itself, but normally I have to take this. Now we're going to see if we can make a crystal ball that stays a little bit longer. So here I'm going to go like this and trap the bubbles. Look how fun that is. That's what you think of when you think of chemistry. You think of bubbling solutions, pouring out of their containers, and having so much fun doing this. So this is sublimation bubbles. Now we're going to have some of my children come and play with this solution, and they're going to be safe while they do it.
Volcano, volcano, come on, volcano.
Today we are learning that dry ice, which is a solid, goes straight from a solid to a gas, especially when you put it in warm water. And that this is a very fun starter activity for anybody that wants to have fun doing chemistry. All right, have a good day. Thank you so much.